Alright, so today we're going to be looking at scientific notation. So scientific notation is a way of writing numbers in a compact form. So let's say that we have a really, really large number or a really, really small number. Either way, we've got a ton of zeros. I don't want to keep track of all those zeros all day. So what we're going to do is we're going to crunch it down into something a little bit more manageable that doesn't look as intimidating as I'll get out. Okay, so let's take a look at this number right here. All right, so the purpose of scientific notation is to write very large or very small numbers in a compact form that are easier to deal with. So let's say I have this atrociously long number right here. Okay, I don't want to have to write all those zeros all day long every time I do a step of a problem. So I'm going to crunch it down into a smaller bit. So when we are doing scientific notation, the first step is to put a decimal at the end of all whole numbers. If it's already a decimal, great. That's one less step you have to worry about. All right, so I'm going to put a decimal right there at the end. Okay, that's step one. Step two, we're going to move the decimal until you get a number between 1 and 10. Now, whether it's a big number, small number, whatever, as long as it is a number between 1 and 10, meaning 1.0 all the way up to 9.9, then we're good. The main thing is it cannot be 10 or greater. It has to be a little bit less than 10, okay? So we have to have just one digit to the left of the decimal place is what I'm getting at. Okay, so I'm going to move this decimal until I find a number between 1 and 10. All right, so I'm going to move it once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And I'm going to put my decimal right there. Okay, 3.62 is a number between 1 and 10. That's good. That's what I want. Okay, so 3.62 is between 1 and 10. 36.2 is not. Okay, so I'm going to leave my decimal right there. And I'm going to write down the number that I get. 3.62. That is my coefficient. The coefficient in scientific notation is your basically standard number. It's usually between 2 and 3 digits. Sometimes a little bit longer if you've got a lot of extra significant figures in there, but not usually. Okay, next we're going to do a multiplication sign times 10 to the power of something. Okay, so write the exponent as a power of 10, so 10 to the x, with x being the number of spaces the decimal was moved. So let's go back. How many times did I have to move this decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a very large number. So this is going to be a positive 12. So if you look in the margins over here, if it's a positive exponent like positive 12, that means that you have a really, really big number, like this number right here. If you have a negative exponent, like if it was a negative 12, that would be a really small number, like a teeny tiny decimal. Okay, so positive exponent, big number, negative exponent, little bitty number, like a decimal. Okay, and that's it. So let's look at some examples of changing from what we call standard notation or regular numbers into scientific notation or this compact form. Okay, so let's look. I have 0.000135. Notice that I always leave that 0 in there as a placeholder. Otherwise, it is not a proper decimal. So I'm going to move this decimal place until I get a number between 1 and 10. So I want to move it 1, 2, 3, 4. Okay, 1.35. Is that between 1 and 10? Yes. Okay, so I'm going to put my decimal right there between the 1 and the 3. I'm going to write down 1.35 times 10 to the power of, I had to move it 1, 2, 3, 4. This is a small number, like a decimal. So I'm going to put a negative 4. Okay? 3.69, or sorry, 36.9. So let's take a look at this one. There's not really much I can do with this. Okay? So I'm just going to move the decimal until there's a number between 1 and 10. 3.69. Okay? 3.69 times 10. This is technically a big number. It is greater than 1. I had to go to the left with the decimal place, so it is going to be a positive 1. Okay? So if you have to go to the left, so left is going to be positive. If you have to go to the right, then it's going to be negative. Now on the next page, we're going to see that changes up a little bit, depending on if you're going backwards. All right, let's see if we have the number 10,000. This is not too bad of a number. It's not that bad. So this is a whole number with no decimal place. I'm going to put the decimal at the end. All right, I'm going to move it until I get a number between 1 and 10. Now remember, it can't be exactly 10. It has to be less than 10. So it can be up to 9.9, but not 10.0. Okay? So 1, 2, 3, 4. Okay? If I had left it right here between that first and second 0, then it would be 10.0. That's too big. It has to be a single digit to the left of the decimal. So 1.0. Now, if you have a bunch of zeros like this left behind, unless it says otherwise, at least leave one of those zeros on there. So it's like 1.0 instead of just 1. Okay? That's just to note that it was exactly 10,000. All right, so 1.0 times 10 to the power of, and I had to move it 1, 2, 3, 4. This is a large number, positive exponent. And I had to move it to the left. Okay, so those are some examples of how we would go into scientific notation. Let's look at some more examples. So let's say that I have 1, 6, 2, 1, 2, 3, 4, 6, 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, that is a really, really, really long number. And I don't ever want to have to write that down again. Okay, let's find a shorter way to write that. Okay, so just eyeballing this, the only number that I'm going to get between 1 and 10 is going to be 1.62. Okay, you can try that out for yourself, but it's going to end up falling right there. Okay, so let's put our decimal at the end. Let's move it over. 1, 2, 3. Uh-oh, look, I lost. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, one more, and 18. Whew, that was a lot. All right. This is a very large number, so it's definitely going to be a positive exponent here. Okay. Great. Wonderful. But, okay, sometimes when you are doing this on the computer or even on the calculator, it's not going to show you times 10 to the power of 18. Okay, if you've ever used some of the calculators at school, you might have noticed that it gives you an answer more similar to 1.62 E18. Or maybe it gives you a capital E, 1.62 capital E18. Those are also acceptable ways to write that number. Okay, these are all the same. Okay, the difference is if you are writing it by hand, I would much prefer this first method, 1.62 times 10 to the power of 18. It's much cleaner, it's much easier to see. If you are typing it out on the computer, though, especially if you're on Google Classroom or something like that, it is almost impossible to put in an exponent like this. So that's where the E came in. Think of it E as in exponent. Okay? Now, whether it's a capital E, lowercase e, I don't care. If the directions specifically say put a capital E or put a lowercase e, obviously follow that. Otherwise, it does not make a difference. It's just based on personal preference. Okay? So that's how you would write it in basically like computer format as opposed to handwritten format. Okay, let's do one more with that. So let's have 0.12345, 1, 2, 3, 4, 5 zeros, and then 1, 2, 3. Okay. So 0.000000123. This is a very, very small number that I really don't want to have to write all the day. Okay, so I'm looking, and I can tell you just by eyeballing it, my number is going to be 1.23. That's the only number I can get between 1 and 10. So 1.23. Okay, so 1, 2, 3, 4, 5, 6. Okay. 1.23 times 10. This is a small decimal. I had to go to the right, which means that it's going to be a -6. So I had to move 6 times. Or, okay, so this is good if you're handwriting it. Or if you're typing it into the computer, it could be 1.23 E -6. Or 1.23 capital E -6. Okay? Those are all acceptable ways of writing that number in scientific notation. All right, one last thing. Sometimes I want to take these numbers and change them from scientific notation back into a standard format because sometimes it's just easier to think about. All right, so this last little section is going to be scientific to standard. Standard being normal numbers, scientific being the numbers with the exponents. Okay, so let's take a look. So let's say that I have 7.81 times 10 to the power of 5. If you are not a scientist, or if you don't do math problems all day long, this probably means nothing to you. Okay? Not as much as seeing a number written in standard notation would. Okay? This method is kind of confusing for people that aren't used to it. It's confusing for people that are used to it. So maybe I want to put this back in standard notation. Maybe I'm trying to do a report and it's just easier that way. Whatever. Okay, so to do this, we're just going to go in reverse. Now remember, positive exponent means it's going to be a big number. A negative exponent means it's going to be a small number. So think about what direction you're going to go before you start moving. Do I want to make this be a big number? In which case you would put zeros on the end and you would go to the right. Or do I want this to be a small number where you would add zeros in the front and make it a decimal? All right, so I'm just going to write it down here again to have a little bit more space, 7.81. I know that I want to move the decimal 5 times. Let's think about this. If I move 5 times to the right, is that going to be a big number? Or if I move 5 times to the left, is that going to be a big number? So I'm going to have to go to the right. All right, so I'm going to move 1, 2, 3, add a 0, 4, add a 0, 5, add a 0, and put my decimal place. So that my answer is 781,000. You can choose to put the comma as a placeholder or not. That is your choice. Okay, let's say that I have 1.35 times 10 to the negative 7. Okay, negative 7 means that it's going to be a small number, like a decimal. So let's think of it this way. If I move it to the right, is that going to make a big number or a small number? Okay, if I move it to the right, it's going to be a big number. Left, it's going to be a small number. Okay, so I'm going to move it 7 times to the left, because this is negative 7, small number. So 1, 2, add a 0, 3, add a 0, 4, add a 0, 5, add a 0, 6, add a 0, 7, add a 0, and a decimal place. Okay, so it is 0 point, notice I always put that front 0 on there as a placeholder. If not, it will be counted wrong. Okay, 1, 2, 3, 4, 5, 6 zeros. And 1, 3, 5. Okay, so this is my standard notation, regular numbers, nothing fancy there. Scientific notation always has to have that exponent incorporated within it, whether it is written like this, this, or this, just depends on how you are looking at it. So a quick rule of thumb for scientific to standard notation, if you are going, if it is a positive exponent, you're going to go to the right, so add right. If it is a negative exponent, like the bottom example, add to the left. Okay, and that's when you're adding your zeros. Alright, so I hope this helps with scientific notation. You're going to have a lot of problems on this because we are going to be doing scientific notation quite a bit throughout the year. Make sure that you are comfortable with both standard and scientific notation so that when we do get to those calculations, you're good to go. Have a good one.